Okay, so this lab is due in next week. Okay, it's due on Wednesday of next week. All right, I had a couple of people email me yesterday about when the graphing lab was due. I don't remember which class it was from now. Well, it's period 4 or 3. Anyway, um, yeah, it's on there. Like if in Google Classroom, it says when it's due. So I didn't answer. That's why. Okay. So what we're going to be going over today, guys, is the need for Speed Lab. Now, this one, here's the good news. There's no procedure. I'm giving you the data, which means you should be able to get this lab pretty much done in class if you stay focused on it. Right? It shouldn't take you very long. So same as usual, we got a problem that we're investigating here. The problem we're investigating is the change in velocity of a vehicle is measured over time. Okay, tells us acceleration. How can graphing help us calculate acceleration, right? We've talked about how you get acceleration from a velocity versus time graph before. Okay, that's going to be a big part of what you're doing in this particular lab. Andrew, question? Shoot. All right, now that we have the right file, now we can do this. Okay, so like we said, the calculating acceleration from a velocity versus time graph is kind of the big part of this lab. Okay, so we got to remember how we do that. Okay, that's not something I'm going to give away because that's something at this point you guys should know. Okay, so our variables are, okay, we're looking at a velocity versus time graph in this lab. So what two variables usually go on a graph? Manipulated and responding. Okay, now when time is involved, time is the, okay, now the way this lab was actually run, it was backwards, but we're not going to do it that way because we want time on the x-axis so that this works out the way we want it. Okay, so what we're going to be identifying those variables. So you got two of them right there. Okay, you just need to explain them. Don't forget to explain them. Explanation is crucial if you want full marks on your variables, so explain them. I think I said that enough times, right? Okay, then controlled variables. Now, for the controlled variables, this is tougher because we're not actually running this lab. So I'm going to describe to you the way in which this lab was run, and that will help you decide on some controlled variables. All the cars on this list were taken to a test facility, the same test facility, okay, where they were all run on the same day, around as close to the same time as possible. And they were accelerated along the same track from 0 to essentially as fast as they would go, or 45 meters per second, whichever came first. Okay, some vehicles were incapable of reaching 45 meters per second, like the Toyota Corolla and the Volkswagen Beetle. Okay, so they just went as fast as they could go. Okay, and that was the end of the experiment for them. Okay, the same driver was used for all vehicles. Okay, so essentially as many conditions as possible were replicated for all vehicles. Okay. Now, back to our stuff here. Okay, so for our hypothesis, okay, our hypothesis needs to work like this. In the if part of the hypothesis, you need to tell me what acceleration is. That should be pretty easy as it's in the problem. Okay, so the if part of the hypothesis should describe what acceleration is. The and part is basically just going to talk about what we're doing here. We're going to be analyzing velocity versus time graphs of various production vehicles. Okay. The then part needs to tell me how acceleration can be calculated from a v versus t graph. Okay, so velocity versus time graph. Pardon me? Yep, that's why it's also in the hypothesis. In the hypothesis where you tell me how you're going to do it, right? Okay, so obviously here it says using the formula slope equals rise over run. I just haven't had a chance to change that, but we don't want to use that. Obviously Google Sheets will do a better job of this. It'll spit this formula out for us, okay, for each car. So that's probably what we're going to want to use rather than slope equals rise over run for any calculations we might end up doing here. It's on, I changed it on yours? Okay, good. All right, so you're going to pick 5 cars from this list. You can pick any 5 cars from this list. It's got to be from this list, okay? You can't go out and look for your own vehicles with acceleration data because I had to find this stuff and then convert it all to metric because nobody has acceleration data like this. It's always in miles per hour and things like that, so it's useless to us for what we're doing. Okay, so this has already been converted for you. Pick 5 cars from the list, doesn't matter which 5. Okay, I would say if you want to, have graphs that are easy to deal with, you probably want to pick 5 that are at least a little bit different from each other, so you get a little bit different data. Okay, now when you build your graphs, and you're going to have to build a velocity versus time graph for each car. Okay, that is, each car gets its own separate graph. Don't try to put them all on one graph because it won't work. Okay, the only way we were able to put the carts from last week all on the same graph is because their time intervals were all the same. The time intervals for these are not all the same. Okay, that's why we have to put them on separate graphs. So what you're going to do, okay, to start out with here in Google Classroom is when you open this, when you go back to your assignment, you're going to have to add a file. Okay, so if we open this, okay, it says here, this is your work, right? Well, you're going to need to create a Google Sheet. Okay, no, just one Google Sheet. You can make 5 sheets in that file. Okay, so we click on Sheets, and what it'll do is it'll generate a whole new file with exactly the same name. Student Code Error, Need for Speed Lab, Actual. Okay, so it's the same name as the assignment. Okay, so I'm going to take that, open it up, and that's where I'm going to put in my data for each car, but I'm going to put them each on a different sheet. Okay, so I might make sheet 1 for the Ferrari, and then I'll go down here and add another sheet. Okay, and sheet 2 I'll use for the Corvette, and for sheet 3 for the Corolla, or whatever cars I end up deciding to do. Yes. Okay, so once you've built the 5 graphs, okay, and you're going to have 5 different graphs, then you're going to paste them all over into your lab report. Okay, just put them one under the other. Everybody follow me there? Yeah? Okay, so we have our different cars then, we have our 5 different graphs. That's essentially going to be, okay, all of your procedural stuff, okay, your data and that kind of thing. Okay, for the analysis, you have a chart like this on your lab already, except it's got enough room for 5 cars on it. Okay, you're going to put in the car, give me the slope and units, okay, give me the y-intercept with units, okay, and then rank the cars from fastest to slowest in terms of their accelerations. All right, so once you've figured out what their accelerations are, okay, then you rank them from fastest to slowest, fastest being 1, okay, slowest being 5. The next thing you have to do, okay, is for question number 3. Okay, so from your data, that is your slopes, okay, which of the cars accelerated the fastest, okay, and then for number 3, using your best fit line, calculate the displacement of each car in reaching 45 meters per second. Now, when you make your graph, is this point necessarily going to be on your line? It's most likely not going to be on your line. Is that okay? Okay, how do I get displacement from a velocity versus time graph? Right, it's the areas under the line, but you need to be mindful of something. Okay, when you build your graphs, you really need to look carefully at what shape they come out to. All right, if you get a graph like for one of the cars, probably most of the cars actually, it'll probably look something like this. Okay, the y-intercept is not going to be 0, is it? Okay, so you have a couple of shapes here. Agreed? So you need to figure out what they are, right? And to do that, you need their numbers. So what you have to do, okay, is you're given a y value here, right? you're told how you need to calculate the displacement that they cover in reaching 45 meters per second. So you know what y is. What can you use y to calculate if Google Sheets spits this out for you? Let's say, I don't know, 5.6x plus 1.2. Okay, so how do, but what, if I was given y, I already know these two things, what can I calculate? Do I need that if I want to find out the area of these shapes? Okay, it's something that not a lot of people think about when they do this, and as a result, they end up doing it wrong. So I'm just refreshing your memory here. Okay, if I'm going to know those shapes, I need to know the height of the triangle and the base of the triangle, as well as the height of the rectangle and the width of the rectangle, or the base of the rectangle. Everyone follow? Okay, without me giving it completely away, which I basically have. Okay, that's as much as I'm going to say on question number 3. No, that's what I just said a minute ago. The point for 45 meters per second is probably not on the line, right? Your line's not going to pass through that point. Therefore, I can't use that point for anything because it's not on my line. With me there? Okay, because your data, for all the cars, your cars are going to go like this. And the data is going to flatten because cars don't accelerate as well in their higher gears. So all the cars will have kind of a flattening shape. Okay, so as a result, okay, when the computer draws the best fit line, in fact, it may draw it flatter like this. It may draw the best fit line like that, which means the point for 45 meters per second is above the line. I can't use it to calculate anything about the average, right? This equation is for this line, not this point. Okay, so when y is 45, my graph is talking about that point, not that one. Okay, points very rarely end up on your best fit line, but you can't use any points that aren't on the best fit line for any calculations. Does that sort of make sense? Okay, you have the line, you have the equation for the line, that's what you can use. Okay, all right, so that's for the analysis. Okay, and then obviously you'll have your conclusion. Okay, so make sure you restate your hypothesis and explain whether you were able to calculate the accelerations and whether your hypothesis holds up based on the shapes of your graphs and things like that. There's no evaluation this time. Why? We didn't run the experiment, so okay, we can't identify any sources of error. Okay, we can identify the variables, but we can't identify really any sources of error without having actually been at the test site. So you don't have to do that part. Okay, so it's a little bit shorter. You're going to have to figure out your sources of error. Okay, so variables, hypothesis, 5 graphs, which won't take you long. You just have to enter data. You guys know how to build graphs. Okay, the analysis questions, the 2 of them there. Okay, filling in the chart, and then basically 2 and 3 are helping you fill in the chart, and a conclusion. You're done. Questions? All right, have at her. If more come up, just ask.